Welcome to this comprehensive introduction to machine learning and its critical role in data analytics. The concept of machine learning dates back to the 1950s, with the evolution of algorithms like decision trees, neural networks, and support vector machines over time. Today, machine learning is a key enabler for predictive analytics, automation, and intelligence across industries. We will be looking at the following contents in this video. Machine learning is a core part of modern AI systems, enabling computers to learn from data, identify patterns, and make decisions with minimal human intervention. Unlike traditional programming, where explicit instructions are provided, machine learning systems use data to discover rules on their own. In the context of data analytics, machine learning has transformed how organizations handle data. Traditional data analytics involves examining historical data to find patterns. Machine learning takes this further by predicting future trends, identifying hidden insights, and providing decision support. For example, businesses today use machine learning to predict customer churn, detect fraudulent transactions, and recommend products. In essence, it brings a new level of automation and intelligence to data-driven decision-making. There are three main types of machine learning algorithms, each serving different purposes. Supervised learning. In supervised learning, the algorithm is trained using labeled data. It's like having a teacher who gives correct answers while the machine learns. This method is often used for classification and regression tasks, such as predicting house prices or detecting spam emails. Unsupervised learning. Here, the data is unlabeled and the algorithm tries to find patterns or groups in the data on its own. Clustering algorithms like k-means are an example of unsupervised learning, used in customer segmentation and anomaly detection. Reinforcement learning. This approach involves an agent that learns by interacting with its environment and receiving rewards or penalties. Reinforcement learning is commonly used in robotics, gaming, and autonomous systems. The machine learning process generally follows three main stages: data collection and pre-processing. Before a model can be trained, we need data. This data must be cleaned, normalized, and structured properly. Missing values, outliers, and noise can affect the accuracy of the model, so this step is crucial. Training a model. Once the data is ready, the next step is choosing an appropriate machine learning algorithm. The model is then trained using training data to learn patterns or relationships in the dataset. Model evaluation. After training, we need to evaluate the model's performance. This is usually done using a separate test dataset and metrics like accuracy, precision, recall, and F1 score. Hyperparameter tuning is often required to improve the model's accuracy. Machine learning is used in a wide range of industries to solve real-world problems. Let's take a look at some examples. Predictive analytics. Machine learning models help businesses predict customer behavior, such as which customers are likely to leave a service, enabling companies to take proactive measures. Fraud detection. In the financial industry, machine learning models are employed to detect fraudulent activities by recognizing unusual patterns in transactional data. Recommendation systems. E-commerce and streaming platforms use machine learning to recommend products or content to users, improving user experience and driving sales. In this video, we covered the fundamentals of machine learning, its types, and how it plays a crucial role in modern data analytics. As data continues to grow in size and complexity, machine learning will remain essential in deriving meaningful insights and making data-driven decisions. Stay tuned for our next video, where we dive deeper into data analytics.